Hey everyone, Sebastian here, back with another video where I categorize every type of question in a specific category on the SAT, and I go through and give you an example for each, right? So I did this before for observational studies and experiments and statistical claims, and now I'm doing it for probability and conditional probability. There are 21 types of questions here that I've found in the question bank. They didn't categorize them like this, but I found them and grouped the ones together. So I have a Google Doc that you can have access to in the notes. I haven't done every category, but you can see that there's percentages, right? There are 53 total percentage questions in the question bank, and there are 30 categories for that, right? Then you have evaluating statistical claims, where I did the full walkthrough. There are 10 questions, and there are 8 categories there. And then it's not all done yet, but for the one we're doing today, probability and conditional probability, 36 questions in the question bank, right, labeled here by which question, and there are 21 types of questions, right? So you don't have to do repeats unless you want to do repeats if you're stuck. But if you know how to do them, you can move on, and this is to condense the education for you, and so that you feel confident on the test and don't feel like you're wasting time going over the same types of questions. And vice versa, if you want to focus on a question, you can now really go in and be like, oh, I need to do these questions here to really nail down probability MA questions, where it's like a 2-condition probability with a multi-column chart. So the link for this Google Doc is in the description of the video. But for now, let's get into the nitty-gritty of this video and see how it goes. So try these out, learn them, and you'll have taken care of a big category. So let's start with the easy one. So the PRO, right, stands for probability and conditional probability. Level easy, and the first type, right, is about probability of one number facing up, either when you flip a card or you roll a die. You toss a fair 6-sided die once. What's the probability it lands with a 4 facing up? So the probability, right, is totals on the bottom, and the thing you want is on top. So we're going to have 6 on the bottom because there's 6 faces, and you want a 4 facing up, so that's 1 probability. So you have 1/6, C, right? I think the biggest mistake people would do is they'd put a 4 on top and do 4/6. But honestly, one of the easier questions you'll see on the test, you really got to nail this one down. So in this one, right, we're still level easy. Now it's category B in the probability section of level easy. And that's where you use a chart to find the probability of one condition. So let's try it. The table shows the number of different shapes of diamonds in a bag. If a diamond is chosen at random from the bag, what is the probability that the diamond will be a triangle? So we're going to do triangle over total. And triangles, right, there's 12. And the total would be 6 plus 8 plus 12 plus 14 plus 26 plus 8 is 14 plus 12 is 26 plus 14 is going to be 40 plus 20 is 60. So we're going to do 12 over 60, which when you simplify becomes 1 over 5, and that is D, right? So that one is not too bad. You just have to add up to find the totals. So let's try the next one. So now we're still easy, right? Category 6, which is about using a multi-column chart with totals given and finding probability. The table shows the distribution of votes 150 students give for a school trip. If one of these students is selected at random, what is the probability of selecting a student who voted to visit Denver? So even if they hadn't told us 150, we get the 150 here, right? And then we're going to do probability of selecting a student who voted to visit Denver. So Denver is here. We have 40. So we would do 40 out of 150. So a little easier than the last one because we don't have to do the sum, and that's going to be 4 out of 15. That is C. Okay, I know these are nice and quick and easy. You probably know how to do them, but stick with this. We're going to be building up. It'll get harder soon. Okay, so here we have probability, right? Still easy, category D, which is about finding the missing value in a chart with a total. The survey is taken of 1,000 marathon runners. The table groups them according to age and summarizes the responses. How many of the marathon runners below age 50 do not take a multivitamin? So this plus this, right, is going to give us 457. And there's a total of 1,000, so we do 1,000 minus 457 to find people under the age of 50. And that's going to give us 543. So 312 plus question mark equals 543. So question mark equals 543 minus 312. So question mark equals 231, and that is B. Okay, so a little more complicated than the last ones, but still easy, still very manageable. Let's go on to the next one, right? These are quick and easy. I just wanted you to see them so you know all the levels and you can practice everything. A bag has 60 marbles, 12 blue, 27 yellow, and 21 red. If one of these marbles is selected at random, what is the probability of selecting a red marble? So here you're just trying to find the probability of one condition. It's similar to PROEB, but there's no chart this time. It tells us the total as well, so that's nice, right? So what is the probability of selecting a red marble? So we're going to do 21 out of 60. And when we divide them both by 3, because that's the common denominator, we're going to get 7 out of 20. And that's going to be C. Okay? So again, not too bad. If you have questions on this or any of the other first four, let me know. I'm going to keep going now. So this is PROEF. A restaurant buys 1,000 eggs a week. On average, 6 of them are rotten. If an egg is randomly selected from the restaurant's purchase, what is the probability that it is rotten? So here we want to find the probability is a decimal, right? We know that by looking at the choices here. So as a fraction, it would be 6 out of 1,000. And that is, look at the answers. It's not 6, right? Probability doesn't even go beyond 1. That would be 60%. That would be 6%. It would be D, 0.006, right? Because that's what 6 over 1,000 equals. And then we have our 7th one in the easy level, right? This is about finding a probability with a constant. So I think it's a little trickier, but still not too bad. There are N horror Blu-rays and 6 comedy Blu-rays on a shelf. If one of these Blu-rays is selected at random, what is the probability of selecting a horror Blu-ray in terms of N? So it's always what we want over total options, right? And here, what we want, right, is horror Blu-rays, which is N. And the total options is N plus the 6 comedy. So that is going to be C. Okay? So again, even though it's become a little more abstract, it's still at the easy level, and you just have to understand what probability means. And this is the last of the easy level questions. A bag contains a total of 48 cards. A card is chosen at random from the bag. If the probability that a card with the letter S will be chosen is 0.375, how many cards have the letter S on them? So in this, you're taking the probability and taking the total and using them together to find the value we're looking for, right? So here what we want, right, is S cards. So we're going to have S is what we want over the total, which is 48, and we know that equals 0.375. So we're going to multiply it by 48, so S equals 0.375 times 48. And that will be, anyone? Yep, that is 18. Okay, and that is C. Okay, so if you have any questions on this one, let me know. But again, it's using the same concept, still the fundamental idea. The probability is what we want over total and finding the value from that. So now we're stepping it up. We're going to the medium level now, represented by the M, right? So we're still in the probability and conditional probability section. This is the first at this level, and it's about 2 condition probability using a multi-column chart. So you can see how the complexity is already elevated, but it still shouldn't be too bad. The table to the left shows information about a store's color and size options for a certain shirt. If one of the shirts is selected at random, what is the probability that the shirt selected will be a size small green? So we are looking for size small, which is here. And then we're looking at greens, which is here. And we're looking for where they intersect, right, which is the 3. So the answer should be the 3, the probability of getting those 3 out of the total, right, because there's no conditions placed on it. It's just selected at random from the whole list. So we do 3 over 150, which equals 1 over 50. And that is C. Okay, so again, it's just there's more information to process, especially if you spend time looking at the chart, but you don't need to spend that much time looking at the chart. You look at what they're looking for, and then you go from there, and they give you the totals, so you don't have to add up all these numbers. It's already added up for you. So we're still in medium, right, category type 2 of this, right, and it's going to be 2 condition probability, but there's no chart in a bag. There are 6 blue, 8 red, 21 black, and 21 yellow marbles. If one of these marbles is selected at random, what is the probability of selecting a marble that is neither black nor yellow? So black and yellow are 21 and 21, so we would add them, and then we would do over the total, which would be 21 plus 21 plus 6 plus 8. That would get us 42 over 56, but we want the probability of it being neither of those, so it's going to be the other 2, so it's going to be 14 out of 56. And that will be 1/4. So our answer here will be B as in boy, right? 1/4. And whenever they have the neither, right, it's just about subtracting the things that they mentioned as being the neither part from the total. And here we have a town has its streets on a grid with 24 intersections lettered A to X with a different letter for each intersection. If one intersection is selected at random, what is the probability that the letter F will be the selected intersection? So this feels more abstract than ones we've done before, but it's actually just as easy as the easy ones. Has kind of a weird setup, but it's still simple probability. There's one letter we're looking for out of a total of 24. So we would do 1 out of 24. That could be an answer, right? Because it's a free response, so you could do fractions, or you could convert that and you would get 0.0416, and then it would sort of repeat from there. Okay, so if you have questions on this one, let me know. The setup makes it feel weirder and more complicated, but it's just as simple as rolling a die. And here, at an NBA game, there are 18,000 fans. Each fan has either courtside seats, regular seats, or boxes. If one fan is selected at random, the probability of selecting a fan with a courtside seat is 0.04, and the probability of selecting a fan who has a normal seat is 0.78. How many fans are in boxes? Okay, so again, this is almost like a neither nor question, right? And you have to find multiple probabilities from it. So we're going to do 0.04 plus 0.78, and that's going to give us 0.82. And then the total of probability, right, is always 1. So it's going to be 1 minus 0.82 to find the probability of someone in a box, which is 0.18. And then we take that value and we multiply it by the total fans to find how many fans are in boxes. So we'll do 18,000 times 0.18. And that's going to give us 3,240. And that will be your answer. That's how many are in boxes, right? So this one's a level medium because you have to find a probability by subtracting the other probabilities from one and then multiply it by the total to find the value, right? So there's a bit more steps. And you can see how you're going from easy to medium and how they've sort of stepped up. Even though probability MC, right, was probably still, I felt like it was kind of easy, but it had, I guess, a bit more abstraction to it. Okay, so on this one, right, the fifth on the medium level, we have if 280 college students register for a math class every day, what fraction of the 2,520 math students in the semester register in the first 6 days? So if it's 280 per day and we have 6 days, we can find the total by doing 280 times 6, and that's going to give us 1,680. And then we're going to take 1,680 and divide it by 2,520 to find the fraction of people who registered, right? So it's not asking for probability, but it works the same way. So that is going to give us, anyone know? Exactly. It's going to give us 2/3 when you simplify. And that will be D. Okay. So this one, right, became medium level because we first had to find the value we're looking for and then divide by the total. But again, not too bad still. I think you should still be feeling confident about questions like this. Okay, so in probability MF, right, still medium. You have another chart again. The table shows the age of students in a neighborhood. Of the students who are no older than 9, what fraction are at least 3? So no older than 9, right? That means you're going from here, here. What fraction are at least 3? That's 8 and 7. So that will be 15 out of the total of 21. And that will give us 5/7. Okay, so this one, right, is multi-condition probability. You're taking a part of the chart, and then within that, you're finding another part. Okay, and this is just about processing the information carefully and without too much questioning, right? You don't want to get distracted by this. This doesn't matter. It just mattered this part here. The math itself isn't hard, but the ability to process information quickly and effectively is what they're really testing. So we'll go on to MG and see how that one is. Okay, so here we have the table to the left shows information about stores, color and size option for a certain shirt. Which color shirt makes up about 1/4 of the total number of mediums. So we're focused on mediums, right? And we have red, blue, green, gray. That's all the options. And which of these is closest to 1/4 of 31, right? So we have 12/31, which is a bit more than 1/3. 8/31, which is close to 1/4 because it's 8/32 would be 1/4, so it's a bit over 1/4. 6 is going to be around a little less than 1/5, and 5 will be a little less than 1/6, so it'll be 8, right? Because we had 12/31 greater than 1/3. 8/31 greater than 1/4, but close. Then we're going to have 6/31, which is less than 1/5, and 5/31, which is less than 1/6. And the closest one, right, is going to be 8/31. And that gives us the answer B, right, for the blue. Okay. So this one, right, is about estimating and sort of understanding what it means to be 1/4 away, or to be at 1/4, and to be comfortable with numbers that aren't exactly what we're looking for, but are close. And on this, right, this is going to be, I think, our second to last medium level question. A cabinet contains 12 black socks and 38 white socks. If one of these socks is selected at random, what is the probability of selecting a black sock? So again, not too bad of a question at all. So the total is going to be 12 plus 38. That gives us 50. And we're looking for black socks. So we're going to do 12/50, which is going to be 0.24. Okay, so if you know how to do this one, you should be in a great position for this, right? It's a very fundamental question, maybe the most fundamental type of probability question. It comes up a lot on the SAT, so make sure to be comfortable with this. Okay, so here we have the table to the left shows information about stores' color and size options for a certain shirt. If one of the shirts is selected at random, what is the probability of selecting a large shirt? So again, not too bad, even though there's a lot of information, right? You're selecting a shirt at random, and what is the probability of selecting a large shirt? So large is here. And it's nice that they gave us the total, 54, and then the total is 150. So you're going to do 54/150. But you can divide by 6 each, and you're going to get 9/25, or 0.36. Okay, so again, nothing too crazy on any of these. Now we're going to go to the last 4 questions, which are all leveled as hard on the SAT. And if you know how to do those 4 plus these 9 medium plus the first 8 easy, you should get every question you see on the SAT that's about probability and conditional probability. Here we have our first hard level question, right? It's about multi-condition probability with a multi-column chart. Let's try it out. 10 people log their 4 daily meals for 2 days. They log the main category of food for each meal and are all pescatarian, so they do not eat meat or chicken. If a person's response is chosen at random, what is the probability that the selected response will be for a lunch meal, given that dairy is the main category of the meal. So the fact that it's given that dairy is the main category, that tells us we only need to focus on dairy. And then it's saying what's the probability it's a lunch meal. There's two lunches where dairy is the main. So it'll be 2 out of the total dairy meals, 17. So our answer will be 2/17. And you can convert that to a decimal, but it's free response. You can just put in 2 out of 17 and you'll be golden, okay? So again, this is leveled as hard, but if you do it outright, it's not too bad at all. So let's try the next one. I think the hardest part is just reading it and knowing that some things don't matter, right? Like the pescatarian part, that doesn't really matter to us. We just work off the actual question they're asking. So let's go to the next one. A person categorizes their meals by the main protein and main carb for each meal. The table shows the distribution of carb and protein for a selection of the person's meals. If one of these meals has a rice as the main carb, the probability that the meal has fish as its main protein is 1/4. What is the value of X? So if we look at this chart, right, everything is filled in. There's no totals this time, except here we have an X instead of a value. And that's what we're looking for. So it says one of these meals has rice as the main carb. So rice, right, that's this here, this whole row, has fish as its main protein. So fish is X. What is the value of X? So when that happens, it's 1/4. So X over the total equals 1/4. So what's the total, right? We're going to do 2 plus X plus 6 plus 3 plus 4. That's the total. So 2 plus X, I'm just going to write it up here so people know what I'm adding up for, equals total. Because that's the pool we're looking at, right? We're not looking at the pool of everything because we already know we're just talking about the rice. And that's going to give us 2 plus 6 is 8, plus 3 is 11, plus 4 is 15. So 15 plus X equals 1/4. There's a lot of ways you could think about it, right? You could think about it abstractly, but let's cross multiply to be safe. So we'll get 4X equals 15 plus X. We can subtract X and get 3X equals 15. So that makes X equal 5, which makes sense, right? We'd have 5 over 20. So our answer will be X equals 5. So in this one, we have another chart, right? This time with percents involved. So let's see what's going on here. And they both add up to 100%. Interesting. A survey is run to see how favorite cardio activity correlates with favorite art form. Focused only on running and swimming for the cardio. Percents are calculated and shown in the table. For the survey, the number of people who preferred to run was 3 times the number of people who preferred to swim. If a person whose favorite form of art is painting is selected at random, what is the probability that the person preferred running to swimming? So the key thing, and I think that makes this question hard, is that they each are 100%, but they're percentages to different things. Because this is the 100% of the people who like to run, and this is the 100% of the people who like to swim, but they're not related to each other necessarily, right? They're related when they're told that the people who prefer to run was 3 times the number of the people who prefer to swim. So if swimming is X, right, this is 3X. So let's say 30 people like books when they swim, right? The 30 swimmers like books most. That would mean that this isn't 45, it's going to be 3 times 45. Okay, so for painting, right, we're going to take the 5% of the running and multiply it by 3 to compare it directly to the swimming, and it would be 15% of swimming. We could also divide the 15% by 3 if we wanted to, but I think multiplying by 3 is just safer and easier because you can always multiply by 3. Some numbers aren't easily divided by 3. So they're both 15, right? Then the probability of the person preferring running to swimming is going to be 50% because it's 15 and 15, right? So it'd be 15 out of the total of 15 plus 15. That would get you 15 over 30, which is 1/2. Okay, so it'll be 1/2 or 0.5. I think maybe this is the hardest question on all the probability questions. So really take your time and make sure you understand this one. If you do, you'll be golden. So let's try the last one. probability HD, which I've actually done a video on already before. So on August 7th, 2017, there were 26,000 people in Hootown. The major occupations in Hootown were teacher, farmer, astronomer, and inventor. By November 2017, the population had increased to 27,000 as people prepared for Christmas and moved back to this festive town. If a Hootown resident in November 2017 is selected at random, the probability that the person selected was an inventor is 0.22. There were n,000 inventors in Hootown in November 2017. To the nearest integer, what is the value of n? So this is similar to other ones where we take the total and the probability to find the value of the thing. So here, right, we're not going to use the 26,000 because we're talking about the November population, and that's 27,000. And the inventors are 0.22, and it's n,000 inventors. So we're going to do 27, and we don't need to do the 1,000 because the 1,000 is going to be accounted by the word 1,000. So we can just do 27 times 0.22. And that is going to give us 5.94. And since it's asking for the nearest integer, we're going to round that up and make it 6. So it's approximately 6,000 people are inventors in Hootown in November 2017. And that means n is 6 because it's 6,000, right? So that is the last one here. Again, if you have questions on any of these, let me know. And remember, I've already done one for a previous category, which was on evaluating statistical claims and observational studies and experiments. So you'll see the link up here for that one. And I also put it at the beginning of the video, like I mentioned then as well. And I'll be doing more of these to really give you the most comprehensive education on the SAT for free, right? That's the goal for this channel, is to give you a free education for SATs and the future ACTs and other tests, but to make you really be nailed down without having to pay and giving everyone the opportunity to do well on these tests and learn. So I hope you enjoyed this video, and I hope your preparation is going well and that it's sunny where you are. And if it's raining, I hope it's cleaning your windows and watering your plants. Bye.